Now we had the cube of the binomial, and a binomial is a number composed of tens and units. So a trinomial would be a number composed of hundreds, tens, units. So we'll look at the math on the board first. And we can say hundreds, tens, and units, or we can say A, B, C. You can do it algebraically. Now we'll look at the formula. First of all, we have to square it. And that gives us A squared plus AB plus AC. Now we multiply it by B and we get AB plus B squared plus BC. And then we multiply by C and we get AC. Of course we always put the similar ones under each other. BC plus C squared. And that there you have the square of the binomial, of the trinomial. And if you looked at it, I don't know if I can hold it up for you to see it. I know, I'll put them together. Here's A squared, and here are two rectangles of A times B, and here are B squared, and here are two rectangles of A times C, and here are the two rectangles of B times C, and here is C squared. And that pattern, of course, will be on every face of the cube. You can all see that all right. So now we need to cube it. So we multiply by A plus B plus C. And we get A cubed plus 2A squared B plus 2A squared C plus AB squared plus 2ABC plus AC squared. Now we multiply by B and we get A squared B and we get 2AB squared and we get 2ABC and we get B cubed and we get 2BC squared. B squared B squared C and 1BC squared. So that's right. Now if we multiply everything by C and we get A squared C plus 2abc plus 2ac squared plus b squared c plus 2bc squared plus c cubed. Now we have to add that up. And we get a cubed plus 3a squared b plus 3a squared c plus 3ab squared plus 6abc 3ac squared b cubed and 3b squared c and 3bc squared and c cubed. You want me to copy down, or you can do it for yourselves? Ready now? Well, you remember after the binomial, this one, you see, follows the same lines. First of all, we are going to get everything of height a, where we multiplied by a. And so if you like to follow this line, you see, as I take the cube to pieces. And I'll put it out as though you were the children, so you'll see it the right way up. So there we have our a cubed. And then we have 2a squared b. And as before, every face which is the square of a will be red, and every rectangle which is AB or BC or whatever will be black. See? So there we get a squared b, 2 of them. And then we get 2a squared c. This is a squared and this is a c. Then we get a b squared, b times b. So we get a b squared. Alright? Then we get 2 pieces which are a times b times c. A, B, C. So we get 2ABC. And then we get A times C times C. So we get AC squared. And B squared is blue and C squared is yellow. All right so far? And you remember with the trinomial, any face which was A squared was red and B squared was blue. So now C squared is going to be yellow. So now we have put out this line, haven't we? Where we multiplied by A. Now we'll put out this line where we multiplied by B. And we get A squared B. So we must put A squared B under, these are two A squared B's, so we must put this A squared B underneath those two. Then we get two pieces which are A, B squared. This is our A, B squared, so those two must go under there. And then we get two A, B, C. We get two A, B, C. Here are first two A, B, C's. We must go under those two. This is B cubed. Which is this one? That's right, B squared C. So we have 2B squared C, and then we get B C squared. And that's B, and that's B, that's B, and that's C, and that's C. So that's B C squared. All right? So now we put out this line, and now we must put out this line where we multiply by C. A squared C. Now we've got two A squared C here, so it has to go underneath those. And then we get two, which pieces are these? Two ABCs, so they must come under these. And then we get two A, yes, AC squared. AC squared. There's our AC squared, so these two must come underneath that. You get B squared, yes, so here are two B squared C. So look at those. And then we get two B, yes, BC squared. Here we have one BC squared, must come under that. So here everything is height A. So that's why we multiply by A, and this everything is height B because we multiply by B, and this is height C because we multiply by C.
Except the last on level B, the last two will be up. Okay.
Good for you now. All right. Now, if we set it out like that, then the children are going to get this, we don't say conscious comprehending, but they're going to see the math behind everything. And they're going to develop this mathematical mind. Now, if set out like that, and it's very, very easy to put it together again, because we start with A cubed, And at first the children are matching the colored faces. Now, a cube is all red faces, so the next two pieces, which are a squared b, they must match the red face to a red face, you see. And then the next two pieces, which are a squared c, again they have to match this red face to this red face, and those two red faces. Now here we have black faces, and we have a b squared, so the black faces must match these black faces. And here we have all black faces, and here. And we get our two ABCs. Again, here we have two black faces, and we have a c squared. So it's so very logical, the cube. So you just take the pieces in order and match the colored faces. So this is everything height A. Now we have a squared b, and the red face must match this red face. Now, black faces, we have a b squared. See, but in the center we're going to have all blue faces here. Oh, wait a minute, I should put these on next. ABCs, and then the center they're all blue faces, so that's b cubed. And then here's a blue face and two black faces, so the blue face goes to the blue face and the black faces to the black faces. B squared c, and here we have two black and one yellow face, so the yellow face matches the yellow, black, black. Now we've built up, that's A, B. Now here's where we multiply by C, and we first have A squared C, and this red face must match onto that red face. And we have our two ABCs. And then we have our 2ac squared. Now we have a blue face and two black faces. So that's b squared c, and the blue face matches the blue face. Then we have our 2b c squared. This yellow face matches this yellow face, and the black faces match. And then we have c cubed, and we have all three yellow faces.
This away from being just a puzzle for the children is how you present it and the layout, right?
Yes, if you just tip it out all over the table and use it just in a haphazard fashion, they truly are not seeing the math behind it.
Now,
And they can build it. As when I took it out today, the last student to build it had built it in a haphazard fashion, and not built it showing the cube of the trinomial, because, partly because you will find that you can rotate each layer. But they had built it incorrectly, and I had to rearrange it.
now, if a child, okay, two questions. First, I've seen a binomial and a trinomial cube that you match the colors on the outside. The container folds down, and then the child puts the cube in. matching the colors on the sides and the inside of the container?
The only difference there is that you have a box with a hinge, two hinge sides, and you have to take it out piecemeal. I find I prefer having this box where you tip it out on the lid and you get your cube on the table all ready to take apart. And what I don't like about the box you're talking about is that there's a picture on each side. There's a picture of each face here. And the picture is smaller than the cube, so you get a picture here with a natural wood edge all around it. You see, you're seeing the square. But I think that's rather confusing.
Now, if the teacher shows the child how to do this, if the child doesn't set it out right, then you give another lesson tomorrow, setting it out right, then I'm wondering, does the child just start setting it out the correct way because that's the way to do it, and then if the child persists in not setting it out the right way, then the child is not ready for it, right or wrong?
The child will already have had the cube of the binomial. So
that,
well, it is important. That is a step that definitely leads up to this. You see, if I removed these two sides, you see, and the top layer, you see, I have the cube of binomial, don't I? They have said that out many times. So they're used to putting that out in the right order. And they're doing that easily before you present this one.
I guess what I'm talking about, what is
I think, you know, before you worry too much about what the child is going to do, you need to handle it yourself until you're really happy with it. You see, you are a little worried about by it still, aren't you?
Well, yeah.
And I tell you something else, you know, a child has a nice, fresh mind. Hopefully, you have gotten them before anyone has worried them about that. The trouble with many of us is that we were so confused because we had to learn math by memorization, and we didn't understand what we were doing in many areas, like multiplication tables. You see, we didn't know what we were doing. We just had to learn them by rote and then use them by rote. And now, there's all in the Montessori method, we let them work the multiplication tables out so that they understand them. And then we let them work their problems with the tables beside them. There's no memorization. And then they can have a little child, which is about as big as this. And if they don't know any combinations, 6 sevens, it only takes them half a second to get the answer. But every time they say 6 sevens, 42, they deepen their memory tract. So most children, by the time they're 8, and I think all by the time they're 9 and 10, know their tables perfectly, without stress. You see, we think you have to work without this stress. Well, now they're just trying out giving the children a computer. Well, a computer costs a lot more than this bit of paper, but it'll do the same thing. You see. But we've been doing that for 40, 50 years. You see. So the children are going to get mathematics without this stress. So I think you've got to realize that every time you see a piece of material, you get so anxious and worried because of this old stress. But you sit down and use it happily a few times, and you'll get rid of that stress before you teach the children. And that's absolutely essential. Well, you have to judge the moment when a child is ready. And very often just one lesson is enough. If you do, all you have to do is to set it out slowly and carefully. Not go too fast and not talk all the time. Perhaps I was talking too much for you. Now, if you can forget about which pieces are A, B, C, and all the rest of it, and I just did it, setting it out, I think you might be a bit happier. because you're not trying to understand it as well as do it, you know. So all the teacher would do, and remember the teacher and the child would be there. Stop and have a little look at it, you know. That isn't really anything so very difficult because you're doing one layer at a time, aren't you? And then the child would see that you're just taking, I'd be doing it down there, of course, I'm doing it backwards. The child would see you taking each turn, really look at it, you see. Of course, you do get the A plus B plus C pattern at the top, you see. So you see a red face, each face that you're going to match afterwards. You look at that for a minute. See, this is red and this is red. Then we can look all around the cube, and we can see that every face is a plus b plus c all squared. It's easier when one does it without talking, isn't it? And nobody is saying the children understand cube root. See? By using mathematical equipment, they do build up this predisposition to understand and to enjoy mathematics.
Square root, working with two numbers, tens and units.
It's about
Cube root is working with
no, the square of the binomial will be tens times units or squared, and the cube of the binomial will be tens times units or cubed. So you can have the cube of the binomial. I think I'd better see you and give you a little math lesson just between ourselves, yes? Everyone else happy?
When do you, what age do you explain, like the trinomial and binomial cubes to them, like, say, like showing the equation and stuff? Is that like when they're in?
Well, that's when they come onto algebra. Probably the Montessori children might do it a couple of years earlier, because we work very much harder. You see, we think that from 5 to 11, children are physically very strong. You see, really, you know how children will get a lot of colds in the winter. They begin to grow out of this between 5 and 7. They build up this, and if they're properly fed and cared for, and if they're allowed, if they're not overdressed and so on, if they go out in all weathers, they get physically very strong. And they're not very prone to diseases much. Yes? And so that is the age when we do give them a great deal of work. So by 6, 6.5, they will be reading well. And I think this is the age where that we are wasting. As an age when they're very anxious to learn, they're just wanting to know everything there is to know. See? And so that our children will probably do it about 2 years before most children. But that isn't the important thing. The important thing is that they do understand what they're doing and enjoy it. So when we came on to doing it algebraically, we would bring this cube out again. You see, and while we did the algebra, they would also handle the cube, so they understood the algebra. And then, of course, they would use that formula for finding the cube root of a number. So that instead of just finding cube roots because you were told how to do it, they would understand why they were doing it the way they did. So the material does always lead on to understanding and then to working in the abstract understanding. But at this point is to, build up this feeling towards mathematics. You need to film me putting the box back. I'm not doing it so well. This one is slightly tight fit. And they do love putting the box over it and sliding it off onto the lid, I may tell you. And when they've had that one and they're doing it easily, then of course they have the one that is in plain wood, see, which is the one I like so much. Well, nice to have a little light relief, isn't it, when doing this on purpose. Now, of course, another thing about the children is that they have worked with the long rods, the pink towel, the broad stair, the cylinders, the knobless cylinders, and they judge size much better than we do, you see, and they are more aware of size. So in that way, I think these things are easier for them than for us, probably. Some of us judge size very poorly, don't we? And you will find that the children who have been in the Montessori department from 2.5, you see, they do manage these things more easily than the ones who come to you late, who haven't had that sensorial beginning, that sensorial training at the beginning.
What age?
I mean,
Look, any age when you haven't had it, you know. I tell you, my oldest student was 83, so any age. See, and you can't really talk about age because you get your children at such different ages. So any time when you think your child is ready for it. Between 5 and 6 might be ideal if you'd had them from 2.5.
Did Dr. Montessori design?
Yes.
It wasn't available before.
No, don't think so. I've never. There was. I don't think there was math material in the schools. See, nowadays they're proliferating mathematical material, but there was almost nothing.
Did she design all the other material?
Not everything. The number rods were Sagans. In her book, she tells you exactly which pieces she took. But in the catalogues, there's a great deal of material that is designed from hers. She was very mathematical.
what are the lengths of the sides? Are they pretty?
It wouldn't matter.
It doesn't matter.
No. A always has to be the longest, and C always has to be the smallest.
But in relation to each other, is
Doesn't
there a
matter.
difference? Doesn't matter.
I mean, it could be 654 all cubed, or it'd be 236 all cubed. You see? But that doesn't matter. All right now? So now you can have and then you can have this, which is very nice. Have a look at. That's fun, isn't it? But it is so nice when it's made in a transparent material, so that you can, instead of having the lining built up as this is, you do actually see which it properly inscribes. Where did you get it?
I borrowed it from a friend of mine who was at the junior high school level. He's a math instructor.
And he made it?
No, it's in
Oh, it's
the
a kit.
catalog right there. So you can construct it. They have all the things exactly.
Yes, I know.
Nesting color.
Turn off. I'm not going to toast this. This box is too small. I think I'm going to get you to make me a bigger box. Right, I think I think one there's been a slight warping in this the heat of that cupboard. So I'm not even going to try it right. It's your husband also.
You want him to make one?
Just a little bit bigger.
Okay.
Oh, that would be wonderful. And I really need a student or many people with different qualities that we get everything. Would you really make me one?
Yes, that would be hard.
Oh, no, it would be very easy. But just that wee bit bigger. All right, then, so have your break and have a look at them.